The dancing space of galaxies, the mystery of interstellar realms. Celestial bodies woven with starlight, the cosmic wonders. The dance of particles, the sound of waves. Untold stories embraced by the cosmic embrace. Beautiful stars, the voice of their light. A silent moment in the fabric of the universe that moves our hearts. The subtle resonance of galaxies, the fragrance of interstellar space. A mysterious moment in the cosmos, the eternal beauty. In today's session, we will delve into the enchanting moments of the universe, the particle and wave nature of starlight, and the celestial bodies in interstellar space. Remember to subscribe, like, and turn on notifications, as they greatly support our video production. Andromeda Galaxy, Milky Way, Large Magellanic Cloud, and Alpha Centauri Galaxy are just a few of the many famous galaxies in the universe. Let me introduce some of them. The 솜브레로 Galaxy is a peculiar shaped galaxy in the Virgo constellation, with a dust lane cutting across its disk, placing it as an intermediate type between spiral and elliptical galaxies. The Small Magellanic Cloud is a satellite galaxy of the Milky Way, located between the constellations of Tucana and Table Mountain in the southern sky. It is an irregular galaxy, its shape disrupted due to interactions with our Milky Way. The Triangulum Galaxy is a small spiral galaxy close to the Andromeda Galaxy, making it the fourth closest galaxy to our own. It is influenced by the gravitational forces of both the Milky Way and the Andromeda Galaxy, and a future merger is anticipated. The S Sculptress Galaxy is a satellite galaxy of the Milky Way, situated approximately 200,000 light-years away. It is an elliptical galaxy, elongated by the gravitational influence of our Milky Way. NGC 1300 is a massive barred spiral galaxy about 6 times larger than the Milky Way, located in the Eridanus constellation. It features 2 spiral arms extending from both ends of its central bar, with a smaller spiral galaxy at the center. M87 is a massive elliptical galaxy located in the Virgo cluster, one of the brightest and largest galaxies. It harbors a supermassive black hole, and jets emanating from this black hole have been observed. NGC 253 is a barred spiral galaxy in the Sculptor constellation, approximately 11 million light-years away from the Milky Way. It is known for its explosive star formation, containing substantial amounts of dust and gas. M51, the Whirlpool Galaxy, is a spiral galaxy in the Canes Venatici constellation, positioned about 23 million light-years away. Its beautiful spiral arms were formed due to a collision with the smaller galaxy NGC 5195. M81 is a giant spiral galaxy in the Ursa Major constellation, located around 12 million light-years away from the Milky Way. It bears a resemblance to our Milky Way and possesses an active galactic nucleus. M82 is an irregular galaxy in the Ursa Major constellation, situated close to M81. It emits powerful stellar winds and jets due to its interaction with M81. These are introductions to some of the famous galaxies mentioned. I will introduce the theory that stars are both particles and waves. Stars are composed of electromagnetic waves, similar to light. Electromagnetic waves exhibit wave properties, demonstrated by various experiments. For instance, the double-slit experiment shows diffraction and interference patterns when light passes through slits, characteristics of waves. However, electromagnetic waves also exhibit particle-like properties, as demonstrated by the photoelectric effect. The photoelectric effect occurs when light strikes a metal surface, causing electrons to be ejected. This phenomenon cannot be explained if light is purely considered as a wave. If light is considered as particles, the interaction of light particles with electrons in the metal can explain the phenomenon. Electromagnetic waves thus possess a duality of being both particles and waves, a concept explored in the field of quantum mechanics, which studies phenomena in the microscopic world. Quantum mechanics has properties distinct from classical mechanics. For instance, observation affects physical phenomena. In this manner, the theory that stars are both particles and waves stems from the duality of electromagnetic waves. This theory forms the basis of quantum mechanics. While stars are composed of massive celestial matter, this matter is made up of electromagnetic waves. Electromagnetic waves exhibit the duality of behaving like both particles and waves, depending on the context. For instance, within a star's interior, nuclear fusion reactions release tremendous energy in the form of gamma rays, a type of electromagnetic wave with much shorter wavelengths than light. Gamma rays, acting like particles, collide or are absorbed, transferring energy. On the surface of a star, electromagnetic waves manifest as waves. When gamma rays interact with other particles, their wavelengths elongate, transforming into light. Light, as a wave, exhibits phenomena like interference and diffraction. The color of light varies based on the wave's speed and direction. Thus, stars are comprised of electromagnetic waves, and these waves exhibit duality by behaving as both particles and waves. The theory that stars are particles and waves is fundamental to understanding the diverse manifestations of electromagnetic waves within a star's interior and on its surface. While it is correct that the constituents of a star's structure emit both particle-like and wave-like characteristics, the idea that the entire star is simultaneously composed of particles and waves is a misconception. Considering stars as a whole in this way goes beyond the scope of quantum mechanics, which primarily describes phenomena in the tiny, microscopic world. Stars are colossal celestial bodies, and the laws of quantum mechanics do not apply to them on a macroscopic scale. The notion that an entire star moves collectively as particles and waves is also incorrect. Stars undergo various movements such as rotation, oscillation, pulsation, or explosion. These motions are determined by multiple factors both within and outside the star, and they are intricately linked to the star's structure and evolution. A star appears as a single entity to our eyes, and the idea that it is a combination of particles and waves until observed otherwise is inaccurate. Even in binary or multiple star systems, where stars form pairs, each star exists as an independent entity. While it is true that the constituents of a star's structure, including light and particles, exhibit the duality of being both particles and waves, it is essential to clarify that the entire star does not simultaneously exist as particles and waves until observed. I will introduce comets and meteor showers. Comets. Comets are small celestial bodies composed of ice, dust, and other volatile compounds, orbiting the Sun and the Solar System. As they approach the Sun, they undergo heating, causing the release of dust and gas, creating a distinctive tail. The tail of a comet extends in the opposite direction of the Sun and is categorized into plasma tails and dust tails. Comets are classified into short-period comets, which orbit the Sun periodically, and long-period comets, which make a single pass. One of the most well-known comets is Halley's Comet, which returns approximately every 76 years. Meteor showers. Meteors are cosmic particles and dust drifting in space, drawn toward Earth's atmosphere by gravity. Upon entering the Earth's atmosphere, meteors heat up due to friction with the air, producing a bright light. Most meteors are remnants of comets or asteroids, with meteoroids being generally small, ranging from fine sand-sized particles to larger rocky fragments. Meteors appear to radiate from a point known as the radiant, and meteor showers occur when the Earth passes through a trail of debris left behind by a comet or asteroid. Meteor showers are named after the constellation in which their radiant is located. For example, the Perseid meteor shower appears to radiate from the Perseus constellation. Both comets and meteor showers offer captivating celestial displays, showcasing the dynamic and interactive nature of celestial bodies within our solar system. I will introduce interstellar objects. The force that propels interstellar objects is gravity. Interstellar objects are celestial bodies originating from outside our solar system, having been influenced by the gravity of other star systems before entering our solar system. Once they enter the solar system, the gravity of the Sun affects these interstellar objects, altering their trajectories. Whether an interstellar object enters and exits the solar system is determined by its velocity and distance from the Sun. If an interstellar object had a higher velocity before entering the solar system compared to the rotational speed of the solar system, and if its distance from the Sun is greater than the size of the solar system, the interstellar object will pass through, following a hyperbolic trajectory. Examples of such interstellar objects include Oumuamua and the Borisov comet. On the other hand, if an interstellar object had a lower velocity before entering the solar system compared to the solar system's rotational speed, and if its distance from the Sun is closer than the size of the solar system, the interstellar object will stay within the solar system. Such interstellar objects follow elliptical trajectories. An example of this is the interstellar object known as 2020 SO. In summary, gravity is the force responsible for the motion of interstellar objects, and their entry into and exit from the solar system depends on their velocity and distance from the Sun. Oumuamua, discovered in 2017, is the first known interstellar object to pass through our solar system. Interstellar objects refer to celestial bodies from planetary systems outside our solar system. Oumuamua has an elongated shape, approximately 400 meters in length and 40 meters in width, resembling a cigar. Upon entering the solar system, Oumuamua exhibited rapid movement, reaching a speed of about 87 kilometers per second. The true nature of Oumuamua remains uncertain. Initially thought to be a comet, its lack of a visible tail led scientists to classify it as an asteroid. However, when it accelerated as it passed the Sun, scientists speculated that it might be a comet, with gas being released, a characteristic of comets. A research team from the United States suggested that Oumuamua could be a hydrogen iceberg, a substance not yet observed in space, formed in extremely cold regions known as giant molecular clouds. On the other hand, a research team from the Korea Astronomy and Space Science Institute contradicted this claim, arguing that Oumuamua could not be a hydrogen iceberg as such entities would either disappear before reaching the solar system or the formation process would be impossible. Thus, Oumuamua has sparked various debates and speculations. Scientists hope that studying Oumuamua may provide clues to unresolved mysteries in the universe, such as the origin of cosmic phenomena or the nature of dark matter. Penetrating the deep darkness of the galaxy, the light that emerges, the beautiful galaxies dancing in the infinite expanse of interstellar space. Stars, in their slow dance, sing the subtle coexistence of particles and waves, deeply moving our hearts. The celestial spectacle woven with starlight is filled with a poetic fragrance. The sound of particles and the resonance of waves give birth to the mysterious mysteries of the universe in the depths of space. Within this boundless cosmos, stars seem like keys opening tunnels through time. In the moment when particles and waves harmonize in song, we transcend the unknown boundaries of interstellar space, feeling the breath of the universe. Beautiful celestial bodies, with their special performance, enchant us, drawing us into profound contemplation of the mysteries of the universe. The enchanting moments of the universe feel like an embrace to our hearts. The radiant interstellar celebration, blending with the serenity of space-time, endures as an eternal beauty. All of this is connected to the secrets we whisper to the universe, and its beauty continues to unfold through the pupils of our eyes.